Hey everyone! So in this video, I would like to take a look at the Pythagorean Theorem. The Pythagorean Theorem is probably the most famous theorem in all of mathematics, and what it does is it gives us a way to relate together the side lengths of a right triangle. What the theorem says is that the square of the hypotenuse is equal to the sum of the squares of the legs of a right triangle. We know this in modern terms as a squared plus b squared is equal to c squared. So what I'd like to take a look at here is I want to talk through one of the many proofs for the Pythagorean theorem. So I want to justify how we know that this little equation is true. And then we'll use the Pythagorean theorem in a couple examples so that we can find the length of an unknown side. So to start off with, let's take a look at one of the proofs of the Pythagorean theorem. This one involves using the area of a certain shape. So here I have a right triangle, and I'm going to label these sides. So we have side A and B. Those are the two legs of the triangle. And then the hypotenuse, I'm going to label this as C. So the Pythagorean theorem, we know that it says a squared plus b squared is equal to c squared. So that's using our modern algebraic symbols to write this out. So the proof for this, what I need to do first is actually need to do a little bit of copy and pasting, and I'm going to rearrange these triangles. So I'm going to take my original triangle, I'm going to copy it, and I'm going to paste it 3 times. So here's my 3 copies, and now I want to line these up, and I'm going to rotate them a little bit. But what I'm doing is I'm going to use the 3 extra triangles. I'm going to line them up with my original one, and I'm going to create a square. So then this one we'll put up here. And our last one, if we rotate this 90 degrees, and then we'll line it up, we have a square made up of our 4 triangles, and then one big square in the middle. So let me label everything we have here. So all I did was just copy and paste this. So A was my short side, so this length is A, this is A, and this has a length A. The longer leg of my triangle is B, so we have B and B and B. And then the hypotenuse, so all of these on the inside, these all have a length of C. So I have overall, this is a square. But what I want to do is I'm going to find the area of this square in 2 different ways. The first way is just looking at the square. So overall, the length of one of the sides of my square, I have a length of A, a length of B, so the entire side length is A plus B. So the area of a square, we take that side length and we square it. So we have A plus B, if I multiply that length by itself, that's going to give me the area of the square. So A plus B squared, I'm going to multiply that out. So this is the same as A plus B times A plus B. And if we multiply that all out, we have A squared. In the middle, we'd have 2 times A times B. And then we have B squared. So that's one way we can find the area of this square. The second way is we can take a look at all the shapes that make up the square. So I have my 4 triangles, and I have a square in the middle. So the area of a triangle is 1/2 base times height. We have 4 of them. So 4 times 1/2. Base and height are perpendicular to each other. So that's A and B. So 4 triangles, and then we also have a square in the middle with a side length of C. So the area of that square, if I take the side length, multiply it times itself, so that area of that is C squared. A little bit of simplifying, 4 times 1/2, we end up with 2 times A times B plus our C squared. So now these 2 expressions, A squared plus 2AB plus b squared, and the second one, 2ab plus c squared, both of those expressions represent the area of my shape. So overall, this is a square, and both of these represent the area, and they both represent the area of the same thing. So that means that they have to be equal to each other. So these two expressions have to be equal. So let me set them equal to each other, and let's see what happens. So here's our first one. That has to be equal to 2ab plus c squared. Now, taking a look at the two sides of my equation, I have a 2ab on both sides. So if I subtract 2ab from the left and subtract 2ab from the right, that's going to cancel out. And all I'm left with is a squared plus b squared is equal to c squared. And that's our Pythagorean theorem. So because we're able to find the area of this shape in two different ways, because it's the same shape, we can set those areas equal to each other. They have to be the same. And what we end up with is the Pythagorean theorem. Now, this is just one of many different proofs of the Pythagorean theorem. There are hundreds of different ways that we can do this, but this is a neat way using the areas of the shapes to help us come to this conclusion. So now let's use the Pythagorean theorem and find the length of some missing sides. So as long as I know two of the three sides of a right triangle, I can use the Pythagorean theorem to find the length of that third side. The only important thing we need is the hypotenuse always has to go in for c in our Pythagorean theorem. So our theorem is a squared plus b squared is c squared. The c, this always has to be the hypotenuse. So this is always the side across from the right angle. So in our first example, the two legs, so 5 and 12, these are going to be a and b. Now, a and b are interchangeable. So I'm going to say that a is 5, b is 12. Across from the right angle, this is our hypotenuse. So our unknown is x, that's our hypotenuse. Plugging this into the Pythagorean theorem, we have 5 squared plus 12 squared is equal to our hypotenuse squared. Now to solve this, we just need to follow order of operations. So we're going to do our exponents first. 5 squared is 25. 12 squared is 144. And we have x squared. So now we will add these two terms together. 25 and 144 is 169. And finally, we'll take the square root of both sides. And the square root of 169, that does work out. So we end up with x is 13. So Pythagorean theorem, our unknown side was the hypotenuse, and it ended up being 13. And that does check out. The hypotenuse in a right triangle is always the longest side. So the fact that we ended up with 13 is good because it is bigger than 12, so that makes sense. All right, let's take a look at the second one. So again, our hypotenuse across from the right angle, this has to be c. So in this case, we know what our hypotenuse is. So we're going to plug 14 in for that. Our other two sides are a and b, the two legs, and again, these are interchangeable. So one of the legs is 7, and then we have our other leg is the unknown. So in the Pythagorean theorem, we have 7 squared plus our unknown squared, and that is equal to the hypotenuse, which is 14 squared. Again, order of operations, we'll square everything first. So 7 squared is 49. We'll leave this as x squared. And then 14 squared is 196. Subtracting 49 from both sides is going to give us x squared is equal to 147. And finally, taking the square root of both sides, we end up with our length for our other leg, x, is equal to the square root of 147. Now this radical, we could type this in to the calculator to get a decimal approximation, or we can simplify this radical. To simplify the radical, we need to take 147 and we're going to split it up. What we're looking for is the biggest perfect square that 147 can be divided by, which is 49. So 147 is the same as 49 times 3. So that's still underneath our square root sign. I'm not really changing anything. I'm actually just kind of going backwards. So instead of 147, we're writing it as 49 times 3. Now I'll move up here. But we have a product rule for radicals, where if I have some multiplication underneath my square root sign, we can actually separate that. So into the square root of 49 times the square root of 3. So each one gets its own square root sign now. The square root of 49, we know that is 7. And then the square root of 3, that has to stay as is. So here is our simplified radical. But overall, the Pythagorean theorem, as long as you know two sides of a right triangle, you can use the Pythagorean theorem to find the length of that third side.